All right, so for the third page of this propositional logic extra practice, we've got two more kind of free from scratch. So again, I would like you, before you watch this, if you haven't taken the time already, to try them on your own and to really make sure that you're looking at the givens, take an idea of what you want to get. So in this first one, we're looking for essentially producing an and statement. Go over to your rules, look at what rules can result in and statements, and keep those in mind and try to look at other rules that you can use with what we have to start getting to the things that we would need to use those rules. So you can kind of think backwards. I think that's a really great way to start these types of proofs, is to kind of look at what you're desiring, what the final result is, and to try to work backwards. So if you haven't already, go ahead and try to take a pause with that kind of hint. Look for the ones that can do ands. Otherwise, let's get into it. So we have our statements and our reasons. So the one thing, let me just talk about that kind of and thing really quick. So for me, if I were looking at this backwards, I would say, okay, well, what rules can result in an and statement? And if I just go down the line, we have conjunction, modus ponens, modus tollens don't result in and, so that's not good. Keep going, keep going. We could technically get an and statement from a De Morgan's law. And really, those are the main two. Like, I know associativity and distributivity do deal with ands, but they deal with them in larger quantities than we want. We just want one singular and. So those are actually our two main ones that we would try to want to work up to. Now, I'll also say that if I'm looking at these, and I'm looking at between conjunction and De Morgan's, I might personally start thinking that it's probably going to be a bit more of the conjunction path. Because if you think about this, we need a Q and an R, and in the givens, they're in completely different statements. So there's no real way for me to combine those statements together to maybe get me to De Morgan's. Maybe I'll surprise myself, maybe we'll get there. But I might just start thinking that conjunction might be a bit better lead, and I might start trying to make choices that kind of reflect that. I think I will actually end up having to use a conjunction rule. So let me write down our givens. So we have two givens here. Now the one thing is, when you have more than one given, modus ponens, modus tollens definitely should be on your radar more than when you're just given one given from the original. When you're given one given, it can happen where you will use a modus ponens or a modus tollens, but it's more likely to be used when you are given more than one given to begin with. So here, what can we start doing? We want to try to get Q's away from P's and R's away from P's and all that jazz. So you can also do this in a lot of different fashions. I'm going to follow the way that I have written on Blackboard, but if you say got R by itself via simplification, which we will do, if you did that first, that's not wrong by any means. You do not have to follow the exact format of mine if it's kind of a separate thing that you're dealing with. So in this case, in the first one for me, I chose to first find that I could get the P by itself by simplification. And it was simplification on line 2. And the reason we're thinking that is to get the Q away. The thing that's probably going to get the Q away for me is going to be my modus ponens, because I have a P implies Q. If I could just get P, then I could use modus ponens. That's kind of the thought process behind that. Because now if you notice, I have a P implies Q and a P, which exactly is my setup for modus ponens. So now, because I just got that P by itself, I can conclude Q by modus ponens. And modus ponens would be on line 1 and line 3. And great, now I've got the Q by itself. So if now I can just get the R by itself, I could just combine them together using conjunction. So now, technically, you might say to yourself, okay, just use a simplification rule. Technically, we should be a little careful here and be very specific, because if you look at the simplification rule, it technically only results in the first thing. So what we should technically do first here is use commutativity on line 2 to now make the R the thing in the front, because then we can actually follow the proper format of the simplification rule to just get R. I know that might seem a little silly, a little tedious, but it is technically the more correct way to go about it. You do kind of need to make sure you're following the pattern correctly. And now that we have Q and we have R completely by themselves, we can join them together via conjunction. And so our last step here is to join those two together via conjunction. And that is on line 4 and line 6. And then we're done. So again, this kind of step in here, the commutativity and the simplification, I could have done that first if that's one of the first things you see. Oh, I could get R by itself by simplification. That could have been done first and then the other stuff could have come afterwards. If it's kind of something that's kind of detached, it can be in whatever order you want. So moving on to the second one on this page, we have some implications going on here. Now here we have 3 givens and we want to result in just P. So again, if you haven't already, go ahead and pause right here and look at your rules and see what could get you just P by itself. Be very careful here and look at all the different patterns you can use. And if you need an extra hint, pause if you don't want to hear the extra hint. But if you want an extra hint, look at the moduses. So the moduses are going to be very helpful here, but otherwise let's go ahead and get into it. We've got our statements and our reasons. And let's put down all of our givens first. Sorry, that should be a Q. So those are all given. So if we're looking to hopefully result in just a P, so there's a couple ways that we could be thinking of this, and it's probably either going to be modus ponens or modus tollens. So note that if we wanted to use modus ponens, if we wanted to result in P, we would want essentially something implies P, and then we would want that something as well. Sorry, this keeps moving around. And if we wanted to set up for modus tollens, the setup for modus tollens would be a bit more interesting. Sorry. Because if we want to result in just regular P, then what we need is we would need a not P implies something and then a not of that something. So those would be the 2 setups we need. Now since we already have something implies P, modus ponens is looking pretty good right now. But also notice that modus tollens is looking pretty good to actually deal with that not Q implies R and the not R. It's actually exactly the setup I need. I essentially have changed those P's with Q's, and you've suddenly got not Q implies R and not R. So we actually have the exact setup for modus tollens to get us not Q by modus tollens. And yes, we should make it a not, where it should be actually very specific and very formal here, which would make the next logical step to just double negate that. Now here's the thing with proofs like this, is sometimes you're just going along and you're doing things that you find you can use, like if you realize you have this set up for modus tollens and then you just decide, okay, I'm going to use double negation. You might not have even had modus ponens on your radar, but now suddenly you have the correct setup. You weren't even thinking of trying to get to modus ponens, you were just using the things that you could use on what you had, and now you suddenly created it. So although I like to personally work backwards and try to think of ways that I can build up to the things I would need to kind of finish it out, you can also just take a look at what you have and see the rules that you can use on what you have already. But now we have the perfect setup for modus ponens. We have Q implies P and Q by itself, so we can conclude P by modus ponens on lines 1 and 5. Okay, now I'm actually going to go through this last kind of from scratch proof that's on the next page, because the last problem on the last page will probably be a video in and of itself. So I want to take the time to do this last one here from scratch. And for this one, we are kind of given this extra rule, so we're told we get to use this for free. It's called the chain rule if we're ever going to need to state it as a reason. So if you want to give this one a try by yourself, go ahead and try it now. So essentially that new rule is telling us if we have two implications where the hypothesis of one of them matches up with the conclusion of the other, then we can take the not matching hypothesis conclusion and essentially create a new implication. So say we have all of these things, so we have a lot of givens here, and I'm going to run out of space if I don't write a little bit small, so I'm going to try to write a little bit smaller here. So we have all those implications, and we want to try to result in not Q. So if we look at our rules and look to see that something that might give us not Q, what's looking good is also those modus ponens and modus tollens. Maybe modus tollens is looking a little nicer because it already has the not in it, but remember, we could always get a not Q and not whatever we need from modus ponens as long as it was a P implies not Q. Alright, but the one thing I notice is that the only thing we can really do at this point so far is to use the chain rule. So notice that we have Q implies S and S implies T. So that means from lines 2 and lines 3, we could link those together using the chain rule to get Q implies T. And I haven't been writing the reasons, and I wrote given instead of reason at the top. So that was chain on 2 and 3. And let me change this to say reasons. So we can use chain on 2 and 3. And now we have Q implies T, and we originally were given a T implies P. So we could use that chain rule again to get Q implies P by chain on 5 and 1. And now it's pretty much great because now we've got the setup for modus tollens. We've got Q implies P and not P. It's kind of like the backward setup of modus tollens. Again, we're looking for the pattern, not the, don't get bogged down in the fact that the letters are in the wrong order, if you will. So we have the exact setup to use modus tollens to get us our conclusion of not Q by using modus tollens on line 6 and line 4. So we used that new rule a couple of times to get us to the desired implication that we needed to be able to use one of the modus rules, and then we were able to use that modus with that extra not P that we were given to give us our desired result. So those are 3 kind of by scratch proofs. Remember, in terms of this class, any proof that I ask you on an official assessment, so a quiz or an exam, will be one where you just have to fill in the reasons, or you might have to fill in a statement, but you'd be given the reason. So it can kind of be a bit back and forth, but it would be more of a fill in the blank type situation than this kind of from scratch proof that I'm asking us to do here. You do have a couple of these in your homework. They're very good practice, but just know that for your assessments it will be a bit more of a fill in the blank type of situation. Let me know if you have any questions about any of these 3 problems. Otherwise, we have that last video to go over the last question.